Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we see the problem of continuity, which is quite difficult as compared to previous problem. Let's see how I am going to solve it in simple manner. The question is f of x is equal to e raised 1 upon x minus 1 upon e raised 1 upon x plus 1 comma x not equal to 0. Is equal to 1 comma x equal to 0 at x equal to 0. So in this problem we have to discuss whether the given function is continuous or not at the indicated point x equal to 0. Now let's see the solution. First of all, x not equal to 0, it means either x greater than 0 or x less than 0. So for x greater than 0, comma, we have x tend to 0 or we can say x raised plus, that is right hand limit should be 10 to 0. Therefore, in that case 1 upon x tends to 1 upon 0. Therefore, 1 upon x tends to, now 1 by 0 gives here infinity. But present case is what? X greater than 0. So here we get infinity raised plus. It means we get infinity answer from right hand side. Secondly, e raised 1 upon x tends to e raised infinity. And therefore e raised 1 upon x tends to infinity. Therefore, limit x tends to 0 plus f of x, that equal to limit x tends to 0. Now 0 plus means x greater than 0, and in that case we have f of x is equal to e raised 1 upon x minus 1 upon e raised 1 upon x plus 1. So that equal to limit x tends to 0. Now here we take e raised 1 upon x common from numerator and denominator. So we have e raised 1 upon x in bracket 1 minus 1 upon e raised 1 upon x upon e raise 1 upon x in bracket 1 plus 1 upon e raise 1 upon x. Now here we cancel e raise 1 upon x from numerator and denominator. So the next step will be limit x tends to 0, 1 minus 1 upon e raise 1 upon x in the numerator and whole thing divided by 1 plus 1 upon e raise 1 upon x in the denominator. Now as we prove, as x tends to 0, we have e raise 1 upon x should be 10 to e raise 1 upon x should be 10 to infinity. So therefore the next step will be is equal to 1 minus 1 upon infinity upon 1 plus 1 upon infinity. So that equal to, now 1 minus 1 upon infinity gives 0 upon 1 plus 1 by infinity, again we get 0. Since here we mention 1 upon infinity equal to 0. So 1 minus 0 we get 1 and 1 plus 0 also we get 1. So finally we get 1. So in this way the right hand limit, that is limit x tends to 0 plus f of x is equal to 1. Let us this denote as a equation 1. Now we consider the second case, that is for x less than 0. So we have x tends to 0, it means we can say x raised minus tends to 0. So it means 1 upon x tends to 1 upon 0. So it means 1 upon x tends to minus infinity. It means here we get answer infinity from left hand side. Therefore, e raise 1 upon x tends to e raise minus infinity. And therefore, e raise 1 upon x tends to 1 upon e raise plus infinity. Here we use indices rule that a raise minus m can be written as 1 upon a raise n. And therefore, e raise 1 upon x tends to 1 upon. Now e raise infinity, it means e into e into e infinite times. And that gives answer infinity. So finally we proved e raise 1 upon x tends to, now 1 upon infinity gives 0. And therefore our left hand limit, that is limit x tends to 0 minus fx, that equal to limit x tends to 0. Now 0 minus means x less than 0. We have limit x tends to 0, e raise 1 by x minus 1 upon e raise 1 by x plus 1. So that equal to, now just we prove as x tends to 0, we have e raise 1 upon x tends to 0. So the next step will be is equal to 0 minus 1 upon 0 plus 1. So we have answer minus 1 upon plus 1, that is minus 1. So in this way we get left hand limit, that limit extends to 0 minus f of x is equal to minus 1. Let us this denote as a equation number 2. So from 1 and 2 we conclude that the left hand limit is not equal to a right hand limit. Limit extends to 0 plus f of x is not equal to limit extends to 0 minus f of x, and therefore the function fx is not continuous at x equal to 0. So this is a required solution for the given problem. Thank you.